This video is presented to you by www.testprepadda.com. From the previous two lectures, I am discussing average velocity vector and instantaneous velocity vector. In this video lecture, I will talk about multiple velocity vectors and variable velocity vector. Now first I'll talk about multiple velocity vector. This is observed mainly during collisions. During such motion, the velocity vector suddenly changes at a particular time. For example, if initially, the object is at origin 0, 0, if I consider two-dimensional motion, then from 0 to 1 second, if the velocity vector is given as this I cap plus j cap, and from 1 to 2 seconds, the velocity vector is given as 2i. Consider this as v1, this as v2. Then what is v average? V average from 0 to 2 seconds. Now to find this, first I'll separate x and y coordinates. What is given? From 0 to 1. From 0 to 1, the x is 1, y is 1. And from 1 to 2, x is 2, y is 0. So if I take 0 to 2 seconds, then x will become how much? 3, and y will become 1. And that is why the average velocity will be written as 3i cap plus j cap by 2. That means 3 by 2 I cap plus 1 by 2 j cap. Got the idea? Here the time interval was 2 seconds. This is about multiple velocity vectors. Now I'll talk about the variable velocity vector. Here suppose the position vector of an object is defined as r is equal to t I cap plus t square j cap. So path I can write x is equal to t and y is equal to t square. The x coordinate as a function of time, y coordinate as a function of time. Then I can find rate of change of this x coordinate, that comes as 1. Here rate of change of y coordinate, which comes as 2t. So what will be instantaneous velocity vector? It will be, since the x coordinate is 1, I'll write I cap plus the y coordinate is 2t, so I'll write 2t j cap. This way we get instantaneous velocity vector, and consider this as case 1. Now I'll take second case. Here the case 2 says, suppose the object is moving under velocity vector which is given as lambda x square I cap. This lambda is constant and positive. It is given initially the body is at x is equal to 1. So what we do here, we can write dx by dt as lambda x square. So I can write 1 by x square dx is equal to lambda dt. Now if I integrate this, I'll get as minus 1 by x plus c, that is a constant when you integrate lambda t. Now what is given? At t is equal to 0, x is 1. So with the help of this, I'll get the value of c as 1. Got the idea? Now substitute this value here. So it will be minus 1 by x plus 1 is equal to lambda t. So x can be found as a function of t time. As a function of t. Got the idea? So in time t is equal to 1 by lambda. If I write lambda t as 1, in time t 1 by lambda seconds, the object moves from x is equal to 1 to x is equal to, or x tends to infinity. Got the idea? T tends to 1 by lambda, then x will tend to infinity. Now we can get the velocity as a function of time. So v I can write as dx by dt here. Now if you differentiate this, you will get lambda upon 1 minus lambda t square. So we are getting this velocity as a function of time. This is very, very important, and this will help you in finding acceleration that we will discuss in the next video lecture. Got the idea? Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.